Well, good morning, everybody. Our first animation here today looks back at the early morning storms on Saturday that went through parts of Nebraska. And I was watching these carefully, just given what we know about the crop that is in the middle part of the country. And these storms were pretty damaging. We're going to come back to them in just a few seconds, but I want to give you a quick layout of this video. I've got a lot of near-term stuff to talk about, including where we've seen some flash drought development, where I'm expecting heavy rains to continue, and then I'm going to talk about what I think these temperatures are going to do as we go forward. We got an update on the hurricane situation coming out of the main development region of the Atlantic, and then I want to present a case for what I think fall is going to look like, and that's going to be the end of this video. So I hope you stick around for all of it. It's going to be kind of a jam-packed Monday morning here for you. All right, what was interesting about these storms, as you've now been watching them on repeat, was the storm that went right into this part of Nebraska. Now watch it again here, because what's left of this storm eventually helped create all that flooding near Milwaukee. I'm not sure if you saw that in the news over the weekend, but it's that storm right there. Now, when you go back to last week and look at where we were anticipating the severe weather, myself included, we were focused much farther to the north of this, honestly. That was where the low was going through parts of North Dakota, Minnesota, into the Canadian prairie. But it just shows you how willing the atmosphere is right now just to produce deep convection. And these storms did a lot of damage. And I'm still getting reports on numerous pictures of the damage over the weekend as they rolled through. And they were followed by more storms that came through on the backside of this. And there was additional damage that happened into parts of Kansas. But if we just take a step back here, let's go over to my slides here I got for you today. I just want to show you right now where we're watching active storms. They are still in Nebraska, Missouri, right over here where Iowa, Illinois, Missouri meet. But then you can see the bigger storm complex that is moving through parts of Kansas. We have some Gulf Coast storms to continue to think about. We're going to come back to more of a discussion on the Gulf Coast in just a few minutes here. But if you look at the weekend totals on precipitation, this is what I've got. Now let's see if we can get an update of this. I pulled that up pretty early this morning. There we go. And some very, very heavy rainfall as this low. You can almost see it in the data here. It like curled its way through Canada. And back on the end of last week, all the severe weather damage was to the north. Another massive squall line that ripped through this area, producing severe winds. We've had daily convection that has aligned the Gulf Coast, and this is very typical of this year. But what is atypical is the lack of any sort of monsoonal signal that's getting into the southwestern United States. We have watched it go very dry from parts of Texas through the mid-south into parts of the northeast yet again. We need to investigate what that's going to mean as we try to finish out a crop here in the United States. I did want to zoom in, though, just to make a point. Let's get the freshest data there. There it is. How much rain fell in and around Milwaukee. They're having their state fair. And we did see that there was just a tremendous amount of flooding across the southern part of Wisconsin, specifically here in Milwaukee. And you can see they even got hit again last night. This is the satellite data from yesterday, just looking at yesterday's storms. So you can see your deeper convection in the southeast, a few larger storms, Kansas, Missouri. Here's more rain moving over this part of Wisconsin, Illinois, sections of Illinois last night as the sun was starting to set. And on the back side of the low that's spinning here, we were able to bring in some smoke. And I have some interesting information for you on this smoke I want to share in just a few moments. Later in the day as the sun was setting, I did notice some new fires here in parts of Utah and Colorado. There had been fires in these regions, but we can see kind of a renewed push of smoke from them. We're still watching quite a bit of wildfire smoke into parts of California as well. But what I want to see here is what do those fires in Canada look like? Because the low that was spun through this part of Manitoba did deliver some rain that helped work against these fires. But on the back side, take a look at the fires that are farther to the north in Saskatchewan here. And the flow around the back side reintroduced some of that smoke and just pulled it straight down to the south on the back side of this low, which is where we continue to watch that smoke kind of penetrate into the northern plains and upper Midwest. I'm going to have a quick look at where the 48-hour forecast is taking us with the vertically integrated smoke content. We continue to see more of it wrapping around the low that's moving toward the Hudson Bay. There it is. And then the smoke from the fires that are here in the southwest continuing to put out quite a bit of smoke deep in the atmosphere across much of that region. Now, what I wanted to share with you was this. I'm really trying to come up with a great way to represent how much of the sun's light has been affected by either cloud cover or from smoke. And there are a lot of different data sets out there to try to do this, but I'll be honest with you, I'm skeptical of many of them, and even skeptical of this one. I don't think it's fully capturing the impact of the smoke. But what it is it's a 45-day solar radiation anomaly map. Now, what is that? We're looking at how much of the sun's light made it all the way through the atmosphere down to the surface. And it is a reanalysis product. So this isn't as though I've got sensors all over the world giving me this kind of information. But it made a little bit of sense. We had the very cloudy conditions that ran up against the coast of California. You're going to see that again in a few minutes when I show you the temperature pattern. But then coming around the base of this, lack of clouds here, lack of cloud because of no good monsoonal circulation here. Then the dryness that worked its way to where we had the wildfires throughout the last 3 months in this area. But then this whole region, due to excessive rain, a lot of cloud cover, and then due to the smoke that's kind of penetrated into the United States, I think is what's driven, the lack of cloud cover. Now, here's what I can't do from this data. I can't tell you that these average anomalies, all right, what they did to yield, for example. I'm just presenting the data as it is, and I wanted you to see it, okay? Now, from this point, we just need to figure out where we're going. And I want to talk about precipitation as a backdrop to this, because from Montana through North South Dakota, well, parts of South Dakota, but then most of Iowa, Minnesota, Illinois, Indiana, we've seen this swath of very wet conditions. We've also watched last week the flooding that moved into this part of Georgia, North and South Carolina. It's a 30-day departure from normal map. And there's a few areas that I'm got a lot of growing concern about. One is here, okay? The Northeast, parts of the coastal Mid-Atlantic, parts of Michigan, as an example, pockets of Texas, and then the lack of any sort of southwestern monsoonal flow at all. We haven't looked at soil moisture data in a while. I'm going to show you what NASA's current projections are on that soil moisture data. And again, you can kind of highlight a few of those areas. So here, getting into this part of Ontario, sections of the Northeast, we can also see that despite some of the rain, their modeling still suggests there are deficits deep. They're not at the surface, but they're deeper down. And we continue to watch the lack of a southwest monsoon, pockets of dryness throughout the Delta and the southern plains, and then, of course, in the Northwest, where we've watched drought continue to build, which we talked about at the end of last week. Now, is there anything coming? Like, what's the upcoming pattern look like? So let's take a look at the newest forecast from the European model. And this is my new mapping system. I worked on it all weekend when I got chances to do so, to kind of improve these maps, make them way faster for you, and make them mobile friendly. But that's a 15-day forecast, just as a snapshot. And I continue to see an area in through here that is drier. Not dry, but drier. We continue to see a lot of storm activity in the southeast. And there's that same familiar corridor of wetter weather. Now, it's not as though every day is going to be wetter, and I'm going to tell you what's going on here in just a few moments. But that's the outlook. And the way that I kind of distill all this down is that this pattern is not nearly as wet as some of the recent forecasts have been. And you can go to agweather.com and look at the timing of these events with my other mapping system. But this seems to be the way the pattern is shaping up as we work our way through the middle of August and get to that third week of August. All right. Now, we'll get back to the details in just a few moments, but I wanted to talk about the temperatures in the mix with this, because it was a hot weekend for some, right? This is just comparing August 7th through August 10th. That's it, to the same time period, August 7th to 10th, for the last 133 years. So if you want to know how this past weekend stacked up, we were cool here and we were cool there, right? And then there was another push of heat in the midsection of the country. And I'm going to come back to this discussion on heat, because I'm very curious as to how things stack up specifically against 1 year, 2010. So if you want to get to that, just fast forward till I get into that analysis. But this heat seems to be transient. It tends to move. And if you want to have a look at a real quick snapshot of what the temperatures are going to do, here's our next 5 days. Watch day 5 through 10. We see another warm-up into this area, but cooler west coast, and then we get past it. Ready? Day 10 through 15, the pattern seems to want to, just oscillate this heat back to this area, cooling things down there. And that's what I want to talk about. I want to talk about this eastern section of the United States here with respect to heat here in a few moments. But to be honest, there's a couple more pressing issues I want to get into, and the first is going to be what's going on with our tropical setup. So right now, the National Hurricane Center's got a 7-day probability of development at 90%, and we're all going to be watching that particular spot very carefully. And here's the reason why. This is sped up pretty quickly here, but what you're looking at is the European ensemble forecast of where tropical low pressure might form. And look at the spread. Watch it again. It's going to start right in through here. Look at the spread on this next potential wave. Some of the models are taking it much closer to the East Coast. Some of the models are wrapping this through Bermuda. And it goes out 10 days, so we're not getting the full evolution of this system. Now, last week, some of the models brought it all the way into Mexico, Texas, Louisiana, and now we're getting a little bit better sense on where it could possibly go. So I want to show you a few different model simulations. I'm going to start with the GFS. Ready? As we play this forward, we're keeping an eye right here, okay? And what we're going to question is the Bermuda high position and strength. For example, see how it's sliding a bit farther to the east? And any sort of a wave that could kick this out, like this low here next Tuesday, that's going to bring with it a shift in the winds along its front, which will be there, all right, and to keep this system away from the East Coast. And that's what the GFS does. See, it curls it around the Bermuda high, keeps it off the East Coast. Now, that was the 0Z run. If you're curious, the full 6Z run should be in. Might as well go have a look at it. This is what it's doing at 6Z, keeping it offshore. So the last two runs of the GFS, very favorable. Let's go look at the ECMWF. And we're out there again. This is the 0Z run. Again, keeping that system offshore. There's a system coming through North America that helps push. The GFS and European both have it, although it's in different positions. And the Bermuda high seems to be strong enough to peel this thing back out to open ocean. We have other models. Why don't we look at the artificial intelligence? Now, this is the 6Z run. It's bringing it much closer to like Cape Fear there along the Carolina coast, Cape Hatteras, but still not hitting the U.S. It even has a following system. Oh, they try to take it right into Florida. That's 360 hours. We all know not to trust this, right? But something to look at here overall. And that's the 6Z run. I'm just curious. Let's go back to the 0Z run. ECMWF AI model, still getting it close to the coast of Carolinas, but that's kind of that's one model kind of giving you that larger threat. What we know is this: over the next 10 days, you've got something to. I've got something to watch so that you know what to watch. This morning on Monday, model evidence is to keep this thing out to open ocean, and we're gonna have to stick with that until we have overwhelming evidence to change that discussion. Okay, so let's just leave that be. What I do know is that the ocean temperatures are in a good configuration to get tropical systems to go if the atmosphere allows. We're quite warm in this whole area, including our main development region, getting up against the East Coast, the Gulf, and the Caribbean. In addition to that, we are still seeing La Nina signals, which is another component of my longer-range forecast at the end of this that I want to talk about here. In fact, you know what? Look at this real quick. These trade winds across the Pacific Ocean just continue to scream and move, which means I think a lot of our discussion at the end of this is going to be what would a La Nina late summer and fall actually mean? And I think it's going to be the way these trade winds affect the MJO position, which I'll show you in a moment, and then ultimately govern the heat and momentum transfer out of the tropics. What is unknown is what could be brewing in the Western Pacific, typhoon-wise, that could rip across the North Pacific and really impact the U.S. So we'll watch all of it. But just wanted to point that out before I went any farther. All right, this morning, early heat up the West Coast, air quality issues throughout the northern plains, upper Midwest. We've got our flood watches and flood warnings out for Kansas, northern Oklahoma, getting into Missouri. And we're going to watch the Northeast finish off with some here and some heavier rains along the coast. If I flip over to kind of just a quick look at what the Storm Prediction Center is saying, plus the excessive rainfall outlook, let's start down here. From this part of Texas into Oklahoma, getting right up here into the very southwestern corner of Missouri, there is a slight risk for flooding, and you can see the next 2 days. But thankfully, no major risk areas of severe weather in the next 3 days. We are going to be watching day 4 across the Red River Valley of the North. That's, getting us pretty far out there in the forecast, but we need to watch the 14th to see the night of the 14th to see if we have some pretty nasty storms here. Overall, take a look at this pattern. Here's some of my new maps, by the way. When you hover, you can actually see the height anomalies now, so see how big these troughs and ridges are. So as we play it forward, that's the wave I'm going to watch right there, coming through the Canadian Prairie into the Northern Plains when we get out there later in the week. That's Tuesday. See it sneaking through. Now watch the follow-up wave. There it is. That's the one that comes through late in the week, and I think we're just have to pay attention to them. The models are, again, dropping deeper troughs along the West Coast. And there's the European model's solution on what could be our next tropical system. What I want to know is out there by day 10, I see trough, and then a ridge in through here, and then some sort of troughing into the lower Mississippi River Valley, or the Delta. And that seems to be heavily influencing both the precipitation and the temperature pattern out that far, especially this ridge. It's a killer on the monsoonal circulation. Absolutely terrible. But we need to see what it's going to do to precip. So this was this morning. Let's just get through this pretty quickly here as we play through the rest of the day today with the high-res NAM. There it is. There's your boundary filling in. This is the reason why the Weather Prediction Center, along with the Climate Prediction Center, have a risk for the heavy, heavy rains in this region, while the broader low moves its way over to Ontario. So that's tonight. Getting into tomorrow morning, take note of what's going on in Alabama. Can you watch right down here with me? There is this weak circulation in the NAM bringing in heavy rains to Alabama, Georgia, pockets of Tennessee, then over to the Carolinas as this sweeps through. All right. Bigger picture, though, I love this set of maps on my website. 5 maps real quick, all of the major maps looking at precipitation for the next 7 days. And they all kind of have a similar flavor to them. Let's just go ahead and open this one real quick. This is the WPC forecast for the next 7 days. There's our heavy rain threat. I do think there's a stretch in here that gets some rain into the northeast, but it's not overly wet, right? I think this is way too generous on any sort of a push of a southwest monsoon, and you can see a much drier region that's here in the western plains getting back into the Intermountain West. There's your daily convection, and remember, this is all ahead of any tropical development, which we talked about a few moments ago. So let's look probability-wise. I think this map is telling on who has the greatest chance at staying drier. Can you see it now? There's that Texas, stretch that goes right in through here over the next 10 days. And what's interesting about this is that the European ensemble is not picking up well on the heavy rains here. This is a struggle in the models in summer. So we're it's like, oh no, there's going to be a 50 to 80% chance of less than a half inch. Yet the near-term forecast, the one I just showed you, has storms here. So that's one of the things we have to be cautious with when we look at these maps. The lower resolution models, especially the ensemble models, they do not handle convection well at all. That's why we just kind of blur our eyes and look at them and try to assess the pattern, not necessarily the details. So we do know, well, actually we just got a new model run in, but it only goes 144 hours. So I'm going to go back to the 0Z. We do know that this area has our best chance of being wettest. And you saw that corridor that continues to show up here of wetter conditions. All right, so we're going to make sense of that, at least by looking at these ensemble averages. All right, so I keep bringing back this idea about this Four Corners Ridge. It's in the GFS 10-day forecast. It is in the European model 10-day forecast. It is also in the AI 10-day forecast. And by the way, there's the AI version of the tropical system. So I'm showing you that because I'm trying to make sense of these week 2 precipitation patterns. And what's interesting to me is how some of the models are handling it with bringing in some convection underneath it. Notice how this part of Texas is white, meaning normal late summer thunderstorms possible. So the week 2 forecasts, I don't know. I would tell you that maybe the best thing to do is to look at the CPC's outlook. I think they may have a pretty good handle on what week 2 might look like. Okay. Now from here, I want to get back into this temperature discussion. I hope you find this interesting, because from mid-June till this weekend, it has been very hot, especially in overnight lows in the Eastern Corn Belt, Mid-Atlantic, Northeast. And that's been our region of greatest anomalies with these overnight low temperatures. Now I want to think about this and put it in the context of 2010. I made this on Friday, but it's still relevant. We're asking questions about 2010 a lot, because if you look at mid-June to this point in August, 2010 had expansive hot nights here, very expansive. And you could say that it's been more concentrated and hotter this year in the Eastern Corn Belt, like Indiana, Ohio, parts of Kentucky, West Virginia, Pennsylvania, and getting over to the Mid-Atlantic, parts of it. But there's no denying that 2010 was a much, much broader stretch of very, very hot overnight lows, and these continued. They just continued all the way through the rest of August. Now, I'm curious about this because I've been hearing just a lot in the Eastern Corn Belt of pollination issues with the crop quality, while all you hear about, even for me, is super high NDVI values, tons of rain, in the Central and Western Corn Belt. So let's look at something here. Indiana, your minimum temperature ranks when you go back, individual years. They're ranked down here, but individual years for June and July. Minimum temperatures June and July for Indiana, going back to 1895. We've had a pretty well-established upward trend since the 1980s. Now, we could make a strong case for this. I can talk to you about precipitable water. Come to one of my talks. I dig into what these trends mean and why they're so significant. Interestingly enough, the upward trend that you see here doesn't match quite the trend we saw from about 1900 to the 1950s. So actually a greater upward trend in that time, although a tremendous amount of variability. We've had a bit more steadiness in our upward trend of temperatures, and 2025 sits right here. That's June and July only, okay? It's the new hottest Indiana overnight lows for June and July. Now, what are some of the other hot years? Well, we had 11 and 10. There they are. We also had 1999. You could toss in there 2002, maybe even toss in there 2005, 1991, 1987. Several of those years had the yields were not high. And so we have to take that into effect. Now, what's changed since the last time we had a big, hot summer overnight lows? In 2010, 2011, if that was the last time that was comparable to this year, sea technology has changed dramatically. And the precipitation patterns are much different this year than they were then. So we need to account for all of that. But there's no ignoring that fact right there. So we talk about high temperatures. This has not been where the stress is. Now, that's not to say for the Northeast or for Florida or for Arizona. But you look from let's go from the solstice till now. It's been a hotter summer, but I'm not going to call this the hot summer, right? I mean, okay. And I'm only talking about these folks and here and here. We've had cooler weather at times in the northern plains, cooler weather in the southern plains. In the marine stratocumulus layer that's just been invading the coastal parts of California, there's no denying that thing has had a huge influence on these temperatures. It's been a cold summer comparatively for the West. Look at this. Now, not Arizona, but for the West. I mean, Arizona's breaking records daily. They hit 118 last week in Phoenix. So I'm looking at all of that, and I want to show you this. Stress degree days. Now, this is what's very compelling to study this year. I'm going to use Dr. Elwin Taylor's metric of 140 stress degree days in the central Corn Belt. You get past that, and we see yield loss. So where are we? Now, this only applies here. Don't try to use it for Texas. They have a different growing season, okay? But have we gotten past 140 stress degree days? Yeah, in parts of Illinois we have. Southern Indiana we have. Pockets of Iowa, Nebraska, South Dakota. I guess you could apply this work here. But a stress degree day only comes with hot afternoon temperatures. This does not account for overnight lows. We need a second stress metric just on overnight lows. I need to just make something simple to look at that. But I wanted you to see these data here to kind of make that comparison. Now, to be very clear, this is precipitable water. What has accompanied this hot overnight low temperature setup has been just an abundant amount of moisture, especially into this part of the country. It's been very dry with the lack of the southwest monsoon, but look at all this. This is one of the big reasons why there's been a 50-year trend in increasing minimum temperatures in summer especially. It's one of the major components. The more moisture you put in the atmosphere, basically the higher the floor is for overnight lows. And this was a year where we had moisture in spades in this area. So what are the temperatures doing? Well, here's a look at today. Very hot northeast, very hot northwest, okay? But don't expect it to stick around like that. That's Tuesday's highs. Getting into Wednesday, Thursday, when the next trough comes in, look at this. Knock the temperatures back off again in the west. The next pulse of heat comes through the central United States. This is Thursday into Friday. Saturday, I mean, it's hot, 90s here. Cool west. Getting into Sunday, that's where we land. And just to show you again, I showed you the European model earlier. Here's the GFS outlook. This is the next 5 days. That's the heat wave coming through day 5 through 10. Look at the cooler weather in the west, cooler weather in Canada. And then this is day 10 through 15. Remember, all models are attempting to put this big ridge here and have flow come over the top of it like that. Hence the cool down in this area. All right. So I told you I loaded you up this week, but let's get out there farther. This is the new outlook from the CPC for week 3, week 4. They released it on Friday. Okay. I don't think anybody's going to know what's going to happen down here given the tropical season that's ensuing. I question this in a big way. But could we go drier here? Sure. Will it be hotter and drier there? I think it will. But there's, this look at near normal temperatures, at least equal chances for them. Look at this precip, though. The GFS, I think their forecast is following the GFS. This is their mid-August to mid-September outlook. And they're like, bring on the monsoon. What? Wetter here. Drier in the middle. Okay, look at the European solution. Again, mid-August to mid-September. Stormier northern corridor. We've seen that. No southwestern monsoon. And a drier signal here where we've been seeing dryness as of late. All right, I could buy that, I guess. But what I'm confused on is this. If we do end up seeing, as the models suggest, from now through the end of August, a whole lot of MJO phase 3, phase 4, okay, that suppresses our hurricane season temporarily, and it gives you this. I mean, how do you get a southwest monsoon when the anomalous flow is going that direction? That's what I don't get. Maybe we see more of these troughs living here. I mean, I just showed them to you a minute ago. Remember all the models? They're dropping troughs in there. So are we going to stick with that? Is that going to be our late summer pattern? If so, expect more widespread warmth in the midsection of the country with only brief interludes of cooler weather. There might be, at times, cooler shots into the east. But that's what that pattern suggests. Now, I'm thinking hard about this because I'm now looking at September. So I went out and made this for us. What have the last several Septembers looked like? With only one exception, from 2020 to 2024, we were drier here, and there was a lot of tropical activity here, like Helene and other major hurricanes that we've seen in the last 5 years. You cannot make an accurate prediction of the Gulf Coast Southeast fall precipitation pattern because hurricanes are such a wild card. But no discernible signal west, but drier Mississippi Valley. All right, what has happened September, October, November when you put composite ocean temperatures together? We've had only one El Nino event, and it was weaker. Most often we favored falls with La Niñas, warm central North Pacifics, warm Atlantic weather, ocean temperatures. And, I would say this is what we might expect to see. 4 of the last 5 years, we had dry fall weather inside here. Now, this is the CPC's September, October, November update. They're going to make a new one of these, next week. Uncertainty here. Early start to the wet season is a possibility. But if you look, the warmer forecast for September, October, November is an easy call for the National Weather Service simply because you look historically for the whole United States, the contiguous U.S., I should say. And we have had an increase in our fall temperatures. This has been well documented and understood for a while. Now, we don't see this in spring. We only see this in fall. In other words, our falls have been getting steadily warmer. And there's many different things you can attribute this to. One of those things, I think, has to do with the way that summer finishes and where the net position of the jet stream has been living. And it is almost entirely related to this right here. Now, I told you last week we're going to have this in-depth discussion very soon. I need to put it all together for you about what is going on in the North Pacific, and I hope a bunch of you have hung on to the end of this video because that is a massively compelling story to our climate situation for the next 30 to 50 years. The fact that the North Pacific has taken on so much heat over the last 50 years. It's a part of the global circulation. It's part of the ocean circulation, and I think it's critical. I think it's removing one of our most important climate drivers with predicting the weather, which is the PDO. I'll get back to you more on that soon. I'm sorry I don't have it done yet. But I'm showing you all this because I don't understand this forecast from the European model. You're going, what don't you understand? This. Now this, oh yeah. I think we're going to have to watch these areas for tropical development. But I'm questioning, are we really wet in this area? So my only question is, what has history taught me? Where did I put that dumb thing? Shoot, where is it? There it is. 4 of the last 5 falls were drier. And I think with a La Nina trying to work its way in, that's what we should expect. So I want to show you the new NMME forecast for September, October, November. To be honest, I think I could make a case for this more than I can make a case for what the European is showing. All right, what does it show? Hey, anything look familiar here? Near normal precip there. Drier setup here. Wild card would be the tropics. No strong, well, this would be the end of the southwest monsoon, but no evidence of that. Oh, and if you bring in a La Nina, you tend to bring in more troughs here that get this going earlier with better chances of rain. And lastly, finally, at the end of this very long video, this is what we're looking at globally. And that is La Nina to the T. See this? Strong trades, descending motion. Everything rises here. So what does that do? That ends up giving us a circulation that's drier in this area, wetter here, and interestingly enough, wetter, earlier start to the South American monsoon. So plenty to be watching going forward. I hope you found this informative because, boy, that was just a lot of stuff coming off the top of my head after a very busy weekend. Matt and I will craft the story throughout this week, and Andrew's going to keep a close eye on the severe weather threat this week, and we'll just chat soon. Appreciate it. Thanks.